Okay, so you can use long division to divide a polynomial by a binomial. And we're just going to be dividing them by binomials. So we're going to take this polynomial in x, and we're going to divide it by the binomial x minus a, where a would be like a 2, a 3, a 4, a number. Your answer will be q of x, your quotient, plus your remainder divided by x minus a. So the components of long division are this. The dividend is your polynomial that you're dividing. The x minus a is your divisor, which is the binomial that the polynomial is being divided by. The quotient, it's like your answer, which is the expression that results from the division, and the remainder r, the value that's left over after dividing. What happens if your r is 0? And then you say it goes in evenly. You have no remainder. Okay, and you didn't always have a remainder, and it's so nice when you don't. You don't have to worry about it. It means that you have a factor. If instead of asking you to do 25 divided by 4, I said, what's 25 divided by 5? Then your answer would be 5, 0 remainder, and you would say 5 is a factor of 25. 6 isn't a factor of 25. Why not? Because you got something left over. And it's going to be the same with polynomial division. If I have nothing left over, then x minus a is a factor of the polynomial. Okay, so we're gonna learn. You're gonna have to check your division statements this way, which is, as you see, exactly the same as multiplying both sides by x minus a. Okay, so that's how you check your division statement. You will need to know this format. And then we're going to do polynomial long division until you hate it, and then I'll show you a shortcut. And then we're going to talk about something called the remainder theorem, which is actually what I just said. If your remainder is 0, it means that you found a factor. And actually, the logic goes both ways. If you found a factor, the remainder will be 0. And the opposite, if the remainder is not 0, then it's not a factor. Okay, so let's do an example. And you have to write really, 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 really small here because they really didn't leave you enough space. And before I start, I'm just going to erase this because I know I'm going to run out of room. Because I have to kind of write bigger for you guys to see it back there. Okay, so here's our polynomial. So divide 9x plus 4x cubed minus 12 by x plus 2. Express the result in this format. So our polynomial in x is this one. Okay, remember when I got you to do that long division, you wrote the thousands first, the hundreds, the tens, and then the ones. You put that in order because you know that if we wrote 7350, it would mean something different than 5073. Same with polynomials. Write them in descending powers of x when you set up the polynomial long division. Okay, so we're going to write our polynomial in x this way. The cube first, so it's a cubic, leading coefficient of 4. Oh, and just like I had to put a 0 in here for the hundreds column, I'm going to put a 0x squared because I have no x squareds. And then plus 9x and minus 12. So before you start, descending powers of x, and if you're missing a power of x, you need that placeholder. So make sure you put the 0 in when you're missing one of them. Okay, so it's the same theory. You're going to look at the first two terms, the x and the 4x cubed. And you're going to say, how many times does x go into 4x cubed? How many x's are there in 4x cubed? How about 4x squared? So you write that there for your quotient. And then you're going to take x plus 2, just like in long division, and you're going to multiply it by 4x squared. And x plus 2 times 4x squared gets distributed, and I get 4x cubed plus 8x squared. And just like in long division, I write that number here, 4x cubed plus 8x squared. And then, I forgot to move my ruler with me. Anyone have a ruler I can borrow? Oh, never mind, got it. It's just clear, I couldn't see it. Draw a line down below, and you are subtracting it all. Hey, this is super important that you put brackets on here and you show your subtraction. I've got 4x cubed minus 4x cubed leaves me with 0x cubed. I have 0x squared subtract 8x squared leaves me with a negative 8x squared. And then, just like in long division, I bring down the next term, plus 9x. Okay, now I'm going to look at the x in my binomial and my negative 8x squared. How many times does x go into negative 8x squared? Well, negative 8x times. So once again, I take that binomial x plus 2, and this time I'm multiplying it by negative 8x, which is going to give me negative 8x squared, subtract 16x. And I take that number and I write it here. Negative 8x squared minus 16x. Brackets around it. A line underneath it. I'm subtracting the whole thing. Okay, forget about the 0. So I've got a negative 8x squared. Subtract a negative 8x squared leaves me with 0. I've got a positive 9x and I'm subtracting a negative 16x. I've got 25x. And bring down the negative 12. You know what to do next. You're going to look at the first term and the first term. How many times will x go into 25x? 25. And then you're going to take x plus 2, and you're going to multiply by 25. And that's going to give you 25x plus 50. And we're subtracting. And 25x minus 25x is 0. And negative 12 minus 50 is a negative 62. And x didn't go into 62. So here's our answer. If I take 4x cubed plus 9x minus 12 and divide it by x plus 2, my answer is 4x squared minus 8x plus 25 and 13 remainder, which is, 13 remainder, I'm still talking about the example, and 62 remainder, negative, and negative 62 over x plus 2. So here's your quotient, here's your remainder and your divisor, here's your polynomial divided by your divisor. Okay, how do you check this? Well, if I'm going to check this, I would be multiplying both sides by x minus a, and I would end up with this equation. So does our polynomial in x equal x minus a times q of x plus r? Okay, so does my polynomial, and what's my polynomial in order? It is 4x cubed plus 9x minus 12. Does that equal x plus 2 times my quotient, 4x squared minus x plus 25, plus my remainder, negative 2. Can you see the 2 in there? Okay, so I guess we want to check that. So how am I going to check that? Well, I'm going to leave the 4x cubed there, and I'm going to give myself a little more space. I have to actually expand all of this. So distributing the x to the brackets, I get 4x cubed minus 8x squared plus 25x, and then distribute 2 through the brackets, and I get plus 8x squared, subtract 16x, plus 50, and I still have that negative 62. Collecting terms. Okay, all the x cubes, all the x squareds got a positive and a negative, so cancel, that's good. I got a 25 minus 16 is positive 9 x's, and then 50 minus 62